Well, welcome. I'll introduce myself first. For those who don't know, I'm Charles. I'm in charge of the Southampton University Human-Powered Aircraft project, which is a student-only project. We don't do it as part of our course. And since 2019, we've been working to design and build our own human-powered airplanes. So let's see, is this? There we go. Okay. So what I'll do in this in this talk, I'll go through sort of some of the background, and then I'll essentially show a lot of pictures of what we've done. I think that's the best way to show what we've been up to. So I'll show you a whole bunch of pictures of everything from beginning to design our first airplane to now building a very improved version, almost our second airplane, because it's so different. But anyway, the story of SUHPA essentially starts in 2010 with, so obviously I wasn't at the university yet, with a professor called Dr. Forrester. And Dr. Forrester got funding from the university to build a human-powered airplane, which is the 2010 aircraft. And it wasn't the best human-powered airplane ever, but it did prove that this was serious, and that he was very serious, and he managed to get more funding, and he was able to build a second airplane, which is the 2013-2015 one, which a lot of people will know as the Guy Martin airplane, which Guy Martin flew for his TV show Speed with Guy Martin, and that airplane was a hell of a lot better than the previous one. But unfortunately, it's sort of speculative, but it seems like the university got a little bit tired with the human-powered stuff and decided to tell Dr. Forrester to stop. And so the 2015 airplane was put in storage in Southampton, and seemingly that was the end of the project. Give me a second here. There we go. Seemingly that was the end of the project, until in 2017, 1 year before I joined the university, there's a group of students who created SUHPA, which is the student society, and they managed to get the Guy Martin airplane out of storage, and their plan was to rebuild it, to just take all the original design and remake it and try and fly it for fun. Nothing happened very much until I joined the society, and I talked to Alec. In fact, Alec Proudfoot, the designer of the Dash, he came to Southampton, and he made some criticisms regarding the Guy Martin airplane, and based on that, I decided that it would be better to try and design my own airplane, and so I did. I designed what would become the Lazarus. And we started building that design in 2019. What happened with the university after that, I just want to touch on it very quickly, is essentially that the university really wasn't very keen on us building a human-powered airplane, because they thought that that whole thing was over ever since the Guy Martin airplane had been put away. And they didn't really realize that I would come along, design one, and start building it in a room at the university. You can see that pictures there. And so when COVID happened, it was quite a convenient excuse for them, I think, and they essentially decided to kick us out, which meant to not let us build our airplane at the university. But thanks to John Edgley, the designer of the Aerocycles, we managed to find a place to continue building the airplane, and that's where we managed to finish it, and that's how we've been doing since. Currently, we don't get support from the university. We do get money from the Students' Union, but that's sort of separate from the university. They give money to all of the student clubs. That's sort of the situation at the moment. Anyway, we moved the airplane to John Edgley's warehouse, and we finished it. We managed to do lots of things that we couldn't have done at the university, like assembling it completely. And we flew it, of course. In June of 2021, we had our maiden flight. And in July of 2021, we had many short flights at the Icarus Cup that I'll talk more about that in a little bit. Right. So the Mark 1 and Mark 2, the way we differentiate them, Mark 1 is the orange one, the one, I don't know if you can see my mouse, but the one from the 14th of June. And then we modified it, and the Mark 2 is the Icarus Cup one, basically. Very briefly to go over the design, because it's not the design of the airplane was based on the previous one for some elements and completely new for all of the aerodynamics, but essentially it was a lot of XFLR5 and Excel. We didn't do any fancy analysis really. I mean, we did a little bit of CFD, but it wasn't useful. Mostly the design was talking to people who knew what they were talking about and asking them, how do we do this? And then telling us, well, I think you should do it that way. That was mostly how I went about designing it. But the airplane changed a lot. The design really was never finished. It kept on changing and being modified all the time. But it's just to say that it wasn't, we didn't spend a huge amount of time designing it. It was more, let's just start building it and get going that way. So I'll go over the build now. Some of you might have seen these pictures in other presentations I've given. They're all the same, but essentially this is just a timeline of the build. We started by cutting the ribs of the wing of the airplane. We cut them out of foam like most others do. We started cutting them on the university's CNC foam cutter until the university realized what we were doing and told us that we couldn't do that anymore. So then we cut them by hand. Which actually turned out just fine. I think it actually took more time to cut them on the machine than to cut them by hand because of how slow the machine was. But we started by making the ribs, and then we started, one of the first things that we did was to install the ribs on our spars. These spars were mostly the same as the previous, as the Guy Martin airplane. So it was very nice that we didn't have to make our spars from scratch or spend a lot of money on carbon fiber. We did end up modifying them and extending the spars and making other changes, but most of it was there, which was very helpful. So we installed the ribs on our spar, and at that point, it really felt like we had made the wing, but obviously not. What followed after that was that we did the same thing on the tail surfaces. You can see over there on the right, there's a part of a tail surface with the ribs, and I decided we should make the tail surfaces first because that would give us some practice for the wings. In hindsight, that was probably not necessary because they're so different, but we did do that, and it did give us some nice lightweight surfaces that we were very proud of. And once we were quite confident with working with Depron and things like that, we started to cover the wing, and that's really when things got really difficult, because anyone who's worked with these thin Depron foam sheets before will know that if you don't do exactly the correct thing, they tend to crack and break and not be nice and smooth. And we didn't know anything at the time, so I was trying to put tape over the leading edge to stop it from breaking when I was bending it. And we started by gluing the Depron with epoxy, which is really strange. I don't really know why, but then we realized, of course, we talked to people, talked to Alec Proudfoot. He told us, here's the correct kind of glue. But it was interesting because we really learned everything from scratch. But we started covering the wing, and you can see over on these pictures the problems. We have this piece of tape over on the Depron to stop it cracking, and you can see that it's really not bent at all because we didn't know how to bend these really. We were trying to use heat and all kinds of things, but it was quite difficult. But we managed to get a good result out of it. You can see, I think, these wing sections, they do look quite good. It's just that it took a lot longer than it really needed to. By the time we got to about halfway through the wing, I had figured out, okay, this is the method that we need to use now on how to bend the Depron properly using heat guns, and it went much smoother after that. But it was a whole, we didn't really have the time to do a lot of experimenting and figuring out. We just sort of had to figure out as we were building the airplane. yeah, and I was strangely worried about the tapering sections, because on our airplane half of the wing is straight and half of the wing tapers, and I was very worried about the taper, because all the ribs all get smaller. But it turned out it was just as easy, which would have been good to know. But you know, it was quite interesting. We finished the tail with these 3D printed tail mounts, which we never ended up actually using in flight, because made better ones. But we finished the tail, we covered it. The tail actually got extended slightly after that, but you know, as I said, we kept modifying everything as we went. So, but that was nice. We had you know, most of the wing and the tail, and that was quite exciting. So that was roughly that was about January of 2020, the point where we had that there. And so that's what we had. Yeah, right around January of 2020, we had most of the wing, except it wasn't covered. We had some fairing structure. We had 3D printed propeller blades, which I'll talk about a bit more later, because they're fairly interesting. But you know, a tail, we were starting to get there. And then what I decided was we'd start on the fairing. Everything was kind of happening at once, but this is the point where we said, all right, you know, we've got a nice wing, it's going well. Let's sort of focus on the fairing a bit more. The fairing was a little bit tricky, because it's an interesting shape, but it's quite straightforward, because it's just made of a balsa with carbon fiber covering it. So you know, it's easy to modify, to just cut off a piece, make it a bit bigger. The problem with this kind of construction is that it's very weak, as you will see later. But you know, we started on that. I made this sort of lower piece with that we nicknamed the breadbasket, because I don't know, in our minds it looked like one. And we started covering it with this orange covering, and I cannot remember the brand of it, but it was it's self-adhesive. So as you heat it up, it covered. It's model aircraft covering film, which is a lot easier to use than Mylar. And yeah, in the meantime, we completely finished the wings, other than the Mylar covering. We made these orange wingtips, which never actually ended up getting used, because they had some problems. I ended up making new ones later, but you know, at the time we thought, okay, that's good, we'll use those. And got on with the fairing covering. And this was right around March of 2020. We had the fairing, you know, seemingly done, with the exception of the screen. At the time, we hadn't realized that it was quite important to have a very nice clear screen in front of the pilot. So we just had Mylar in this sort of, you know, right in front of the handlebars of the bike. And that wasn't very good. We you know, I showed what we were doing back in the summer of, you know, later. I showed what we were doing, what we had done to the ICHPFC, and some people said, you know, you really ought to put some proper clear, like Lexan polycarbonate screen, so that you can see really well. So we did that, but at the time, that's what it looked like. And this was right around the time that COVID hit, and that everything stopped. Yeah, these pictures, we did a wing test assembly in the room, because we couldn't take it out of the room. Physically, it was fine, but the university wouldn't let us take it out of the room. And so we did a test assembly inside of one half of the wing, and it just about fit. But it showed, you know, everything was straight and it wasn't warped or any of that. And these pictures, I think, were taken the day before the university shut down because of COVID. The day before, 2 days before, something like that. It was, yeah, it was interesting. But you know, it was getting there. And so yeah, and so then everything shut down for COVID, so we didn't have access to the airplane anymore. But you know, I was very keen to keep on working on it. So the next thing I got on with were the propeller blades. On some of these pictures, if I go back, yeah, you can see these propeller blades with the yellow tips. These I had made before. They were prototypes. They were made from the dash prop, cut down with the tip and the root cut. And the way they were made is that they were 3D printed in sections, glued together, and then there was an aluminium spar. You can see it in transparency on this picture, the spar. we never ended up using these blades because they weren't very well made due to being prototypes, and the you know, just taking an existing prop and cutting it was, yeah, I decided to just do my own design. And so I designed my own propeller blades, which were these, and I using the same method of printing the cores and gluing them together to get this. And then I made one set, which is the white set, which has an aluminium spar in, just like the previous ones, except it's a lot better made. And we tested this set, and it worked very well, but we never used it to fly because it just, you know, we made a better set, which is this one. And these are the carbon fiber blades. And those are done using the exact same method, except that the spar only goes in about, what, 30-40 centimeters into the blade, and the rest is just a carbon skin that handles all the loads. And they're a bit lighter and a bit stronger than the white ones. And those are the ones that we used for all of our test flights. And I made them right behind me in front of my kitchen during the lockdown, well, sort of during the lockdown, while we didn't have access to the airplane, because that's kind of one of the smallest parts that I could make at home. And then eventually I got the email from the university telling us, well, it was great with your project, but you can go away now. We're not going to let you work on it anymore. And so I sent an email to John Edgley, and I said, you know, John, can you give us any kind of space to put our airplane? And he said, yes, of course, I'll help you. And so we took it to Wiltshire, and that's where we were able to do to take this picture, do the first full test assembly of the airplane. By that point, it wasn't quite finished, but so that was around, I think that was around February of 2021. So, you know, it was quite excruciating if you think about it. There was 1 year between getting the airplane almost finished and actually being able to assemble it because of COVID and university. But we got there. So that's what it looked like then. So you can see now the screen, you can see this, the bit in front of the handlebars looks a hell of a lot clearer. And so that was the airplane all assembled. With the propeller, you can see the carbon propeller and everything. It was not ready to fly by then. The drive mechanism was not working properly. The chain kept coming off, and we had no control system. The electronics weren't finished. But apart from that, it was almost done, but it wasn't quite ready yet. So we made those modifications, and then and I organized the testing. Organizing the testing was interesting because I contacted Lasham, and they got back to me saying, no, we can't let you because of COVID. So then I contacted another airfield on the Isle of Wight, and they said, yes, of course you can come, no problem. And a week beforehand, or maybe a week and a half beforehand, I double checked with them, and they said, oh no, you can't camp, you can't set up your tents at all on the airfield, which of course we need to do because we can't afford to pay for a hotel. And so that kind of put everything up in the air. But then I contacted Lasham again, and they said yes, this time they were happy. So we went to Lasham, and that's what, around the time I realized the wingtips were really not very good. So I made new wingtips, which are the ones that you can see here, one of them. And those were completely covered with foam, really for sort of simplicity purposes and making it really easy to repair and things like that. But those are the ones that we ended up flying with. Also, we made modifications to the wires. We added turnbuckles, made new tail mounts because the 3D printed ones really weren't very good. All of the parts that we replaced had passed their load tests. You know, we had load tested them and they worked without any trouble. But I wasn't very happy with them. So I decided, well, let's just make new ones. Worst case scenario, we have spares, you know. So after that, obviously we took the airplane back to John Edgley's, and you know, not too much happened because then we had exams and things like that. But then the ICHPAV Cup came about, and the ICHPAV Cup, for that, I decided to make some changes. I rebuilt the fairing, right? Obviously the previous fairing had been very damaged, and we made it look quite good, but it was still very damaged. So I rebuilt the fairing. I reused as much of the old parts as possible, but it was mostly new, recovered it. I changed all these little balsa bits everywhere to try and simplify it so that there'd be less things to break. So that happened. Also added some pulleys to the chain, made a new rudder, a much bigger rudder, which in hindsight was probably not such a great idea. I think that the old one would have probably done fine, but you know, I did that anyway. And I inverted the elevator. So I had put the elevator underneath the boom so that I could move it further back. There's no point flipping the elevator over, it doesn't do anything. But in our case, it meant that I could, because of the geometry of the tail, I could move it further back to get more stability. And we made a few other little changes. And so we took the airplane to the ICHPAV Cup. And we also transported it in a van. But at that time, we didn't have to keep it outside because we could keep it inside of the marquee at the ICHPAV Cup. And so we had quite a few nice short flights. Again, the airplane never flew for very long, just a few seconds because, again, of the power requirement. But, you know, we were able to get it to come off the ground again and again, and we had many takeoffs. And it was quite good fun. The weather was not amazing, but the winds were quite low. So it turned out that we could do a fair bit of flying. And in fact, we flew, I believe, every single day where it wasn't raining, we were flying, trying to fly the airplane and doing lots of hops. And yeah, that's my favorite picture with Lewis in the airplane from the ICHPAV Cup. This great long thing that you see in the front was an attempt to adjust the CG because we thought that the airplane was too tail heavy. So it was a long carbon tube with some water bottles at the front, and it worked really well. It had no right to work as well as it did, but it did work well, and it helped the airplane be a bit more stable. And so we won the Formula Flight Prize for a new British human-powered airplane. What was very clear from the ICHPAV Cup, though, is we took the airplane to its maximum. And what I mean by that is that the airplane, you know, it did all it could, but with its weight and, you know, and the other things and the bike in there, the position of the wheels, I think this was about as best as it could do without a major design change. So the major design change in question is called the Super Lazarus, and it looks like this. So this is all our design. It obviously bears some resemblance to Aerocycle, but it isn't copied off of Aerocycle. It has the same wing, the same rudder, the same propeller, and that's it. Everything else is different. So new fuselage, drive mechanism, wing attachment, elevator, obviously seating position, because that's a recumbent. The most important things, though, is that the wheel, the main wheel, is positioned very close to the center of gravity. That's the main reason, I think, why this airplane doesn't work that well. It's because to take off, you need a huge amount of power because the wheel is really far back. And it's very difficult to get enough speed to just seamlessly get in the air like that. So you have to rotate the airplane a little, and that's very difficult. On this one, the wheel is very close to the center of gravity. The center of gravity is the red dot there, and so it should, hopefully it'll make it a lot easier to take off. So we've already started building it. We decided to make our own carbon fiber tubes for the frame. So these are pictures of us doing that. We built an oven, which is just a foam box with a hairdryer blowing inside of it. Obviously, it's not an autoclave or anything, but it does the job. It helps cure them quickly, and it does make them a bit stronger. And we made the tubes in wet layup. So we bought the dry carbon, put the resin in ourselves, and wrapped them around cardboard tubes to make those. Obviously, to save money, because this method cost us £500 to make the tubes. It would have been way over £1,500 to buy the tubes, so it saved us a hell of a lot of money. We glued the tubes together into a frame, and then we used more carbon to actually properly connect them together, as you can see there. Yeah, we made the paper templates to cut them with a Dremel tool. And there we go. So that was the frame of the Super Lazarus. The frame itself weighs 3.5 kilos, which, you know, it's not the lightest thing ever, but for something that was as cost effective, I think it's quite good. And then we started putting the landing gear in. We made the seat. So the seat is made with a bent piece of foam. There's like a rectangle of foam that gets bent into the correct shape, with carbon fiber on either side, and the little sort of spine support to give it some stiffness. And it weighs 450 grams, which I believe is 150 or 200 grams less than the seat on Aerocycle. And it really works very well. I've pedaled it quite a lot. I'm quite heavy, and lots of people have been in it, and it really does seem to be quite a good seat. So it's quite nice. It seems to be a good method. Of course, we installed the seat, the drivetrain, and so this is sort of roughly what it looks like currently. We've got the frame, we've got the drive mechanism, the propeller on, the seat. The seat is adjustable, slides forward and back, landing gear, pedals. So I would say mostly the difficult bits we've already done. And currently we're looking at around 10 kilos of weight saving compared to the previous one, which should really help with getting longer flights. You'll notice as well, the drive mechanism has the chain on the outside of the frame. And the reason for that is because the internal drive shaft that Aerocycle uses, I think, is a bit too complicated for us. We don't have machining tools, so this is much simpler, and that's what I decided to go for. And recently we've started on our fairing. This is how we're doing the tub at the bottom. This has been reinforced with carbon fiber, and then it's going to have these foam ribs cut out to make space for the airplane, and it's going to be attached and then covered with mylar. Currently it weighs 500 grams. It's probably going to weigh around 700 grams when it's finished. But really, and it's you know, it's not as strong as a composite tub, but the main thing we're trying to do is save weight. That's the most important thing. So it makes sense to do that. And there you go. That's where we are at now. This is the most recent thing that we've built, and our goal is to finish this Super Lazarus for the Icarus Cup this year, the 2022 Icarus Cup. Hopefully finish it a bit earlier so we can test it first and then take it to the Icarus Cup like we did for the previous version. But that's what we've been up to, and I'm really hoping that airplane will be better. I think it will be quite good, because in theory it should be the same weight as Aerocycle with the same wingspan. So, you know, theoretically it should fly in a similar way, hopefully. But that's where we are now, and that's the end of the talk. So yeah,